So, well, we'll take a little bit of time here and we'll run through some slides on Ice Age in Kansas. And before we get too crazy, though, I would like to take a minute to set the stage, just to make sure that we're all on the same page as we go through things. Number one, I am not a geologist. My training is of biology and specifically entomology. So I want to preface everything I have to say tonight by saying it's just a distillation of a lot of stuff I've read. And we'll go from there. Feel free to ask questions as we go through. For myself, as I go through the literature and read things, I ask lots and lots of questions. And my goal is to find out answers. And a lot of times, I have to counterbalance what I'm reading with what I am observing. Sometimes what we observe and what we read don't jive. And so we got to not be afraid of asking questions. And we also, I think this is really important, whether we're operating from a creation perspective or operating from an evolutionary perspective in our science. I think it's absolutely critical that we stop and say, you know what? I'm not God. I'm not omniscient. I don't know everything. And therefore, it's okay for us to say, we don't know. I think it's appropriate for us to say, this is what we know. This is the evidence. But a lot of times we have to, we make a jump into the speculative world. And I think we need to make sure that we are full disclosure when that happens. So we're going to do some of that tonight and practice that. And one of the things I also want to point out is all too often we have a tendency to overlook the fundamental assumptions, as I call them. In our world today, because we don't know everything, we make these things we call fundamental assumptions. And sometimes fundamental assumptions, when we really start to look at them, are really that's their assumptions. And they're not really testable. They're not verifiable. Or to test or verify would be a lot of hard work and a lot of money and effort. And so we never get around to doing that. So sometimes fundamental assumptions can be tested, but because it's so difficult or challenging, we just don't do it. Or sometimes we're afraid to do it because we really don't want to know that the assumption is wrong. And so, unfortunately, a lot of times these fundamental assumptions are going to be determined by our worldview. We're going to make the assumption before we ever even look at the evidence. And as a creationist, I think we can sometimes admit that we do that too. But, it's fundamental assumptions are everywhere in science. They're everywhere in everyday life too. And like I say, we just sometimes don't even realize we're making them. Naturalism is a philosophy, it's a worldview that is based on a fundamental assumption, and that is that all there is matter and energy. That's it. Well, that's an assumption. That's uniformitarianism says the key to the past is the present. Now that's a little more easily tested, and as we look at the literature and we look at the world around us, we see that maybe the present isn't always the key to the past. And I think we can make some very strong arguments there. But still, much of the world is going to operate under this fundamental assumption that the key to the past is the present. Everything happened in the past just like it does today. Another one we might run into is in dating systems when we're looking at, radiometric dating. We're looking whether it's uranium, lead, or any of the others, carbon-14. there are assumptions such as, oh, no parent or daughter material moves in or out of this system in the entire time that the system is in place. Well, that's interesting. I like to point out to students that, one of the things that the United States has never developed and put into use is long-term radioactive material storage. The government has spent billions of dollars developing a location called Yucca Mountain. It's supposed to be the most stable geologic structure known, so that we can lock up this radioactive material for hundreds of thousands of years and not have to worry about it polluting the environment. Why did they cancel it? Why did they never put anything in it? Well, there's a chance that water might move that material out after all. But yet we're sitting here saying that, quote unquote, 65 million year, 85 million year old fossils have never had water move anything in or out of them. And they're in a wet environment? Really? That's a fundamental assumption. And so, we need to be aware of fundamental assumptions and not be afraid to identify them and call them out as we're going through things. So, we also need to look at the difference between empirical and historical sciences. Empirical science, this is what we think of when we say, oh, science. We're going to observe. We're going to come up with questions. We're going to come up with a hypothesis. We're going to design an experiment. We're going to design an experiment to test that hypothesis, collect our data, analyze it, and come to a conclusion. The hypothesis is correct and supported, or it's not supported by the data. That is empirical science. That's what we're taught about in schools. And we talk about how science is supposed to be repeatable. And, scientist A in Cambodia should be able to do the same experiment as scientist B in the United States. That's empirical science. This is what we refer to as controlled experiments. And then we get into historical science that somehow or another never gets mentioned in education. Wonder why. Because we really like to play a shell game here where we mix the empirical with the historical, and we like everybody to think that the historical is actually empirical. But there's a problem here, and that is that the historical involves looking back in time, and by definition, none of us can go back in time. It's just not doable. We just can't go back. So we cannot repeat conditions. These are one-off events. We can't go back and repeat what happened in the Ice Age. Now, some people seem to think that we might need to do that. There's companies out there now selling, taking money to send up balloons into the upper atmosphere to release sulfur dioxide to try to cool us down so that we could, anyway. But these are one-off things. We can't go back and repeat them. They're not based on the repeatable empirical science, but they're also very frequently influenced by the worldview. If you assume naturalism, all there is matter and energy, you've just defined the sandbox in which you can play. You cannot entertain any other ideas that might take you outside of that sandbox. Wow, there's a toy truck in that sandbox. We got to explain how that toy truck got there, but we can only use the stuff in that box to explain it. Can we come up with some convoluted hypothesis on how that little toy truck evolved into that sandbox? Well, we observe long enough, we'll see some ants and maybe some grasshoppers and some other things come in and out. And Wow, they must have really been good engineers. They must have a little foundry. They must have a oil refinery to get that plastic and that metal. They must have made that. Yeah, we can come up with some crazy idea, but if we predefine how we can address the issue, that limits what we can come up with. And that's a lot of times what we're doing with the fundamental assumptions that are frequently attached with worldviews like naturalism. Oops, wrong button. But we mix the historical with the empirical. We mix them together. There are some aspects, paleontology is a great example. Geology is a great example. We can do empirical work there. We can do repeatable experiments. We can go over here and find the prettiest crystals in Doc Rock's display case, and we can destructively destroy them and find out exactly what chemical elements make up that crystal. Don't tell Doc Rock that we did that. He might get upset. But we can do that. But then, we pick up something like a little clay figurine at an archaeological site, and we can say, hey, we got a little clay figurine, we can measure it, we can weigh it, we can document all of its empirical facts. But then we jump off into the speculative. Oh, we think that this was a child's toy. Or, no, this was an idol. And it was used in such and such and such and such a manner. There's all kinds of things that we can get ourselves into trouble with here. But one of the clues that you're getting into the realm of the speculative is the fuzzy words. Could have, might have, may have, all of that good stuff, most likely. And it's interesting, you go to the primary literature and the researchers frequently use that language, and they are being honest. But what happens when you go to the popular literature or the textbooks? All that language tends to disappear, stripped out, cleaned out. We know that there were 4 to 5 different ice ages. Really? Do we? Dr. Ord can tell us about that. But anyway, now that we've kind of set the stage, let's jump in to the ice age. I was really excited to see that you used the sloth instead of Scrat the squirrel for your presentation. But we're going to dive in here. So we'll start out by mentioning the different ice sheets of the North American Ice Age. And I find these maps to be fascinating. They present them exactly like, wow, this is it. Well, is it? We see that there's 2 different ice sheets here. One in the west, one in the northeast, and the one in the northeast extends clear down into, northeast Kansas and Missouri. But how many of you guys have ever been to the mountains of Colorado? Have you ever noticed that there's glacial moraines there? If you go to Rocky Mountain National Park, they even talk about, roads with names related to the moraines and, different, this is such and such, glacial area or whatever. Do you see any mountain or any ice fields in Colorado? You see anything in Wyoming? You go to Yellowstone, you'll see signs about glaciers. There's not any glaciers at all out there in the western United States in the mountains. Isn't that interesting? They were there. So again, we have to balance what we read with what we observe, see out there. You know, maybe this isn't exactly what was out there. But anyway, we'll zoom in on our area. We're supposed to be talking about Kansas, so we'll come down here to Kansas. I don't know if you're familiar with the Kansas geography or not, but northeast Kansas, we have Kansas City, Lawrence, Topeka, Wamego. This would be Manhattan, and the Blue River, Big Blue River. And this would be Tuttle Creek Reservoir up here. And of course, there's some other little reservoirs in here. I point those out just because we'll see them in some other maps coming forward. But, you know, as we talk about and read about the Ice Age in Kansas, the Kansas Geologic Survey will describe 4 to 5 different Ice Age events, and they will say only one of them actually made it into Kansas, and that would be the pre-Illinoisan ice expanse or extension. So the evolutionary geology perspective is that there were multiple ice ages. I've seen in some articles up to 30 different ice ages over a period of several million years. You know, in fact, there are those who would subscribe the ice ages to the Milankovitch cycle, which is a wobbling of the Earth as it goes around the sun, and the Earth tends to wobble on its axis, and you go get further and closer to the sun, and they say that the Milankovitch cycle is going to come and go about every 100,000 years. So about every 100,000 years there should be an ice age. Well, they map out what they think is the different climatic cycles based on proxy data. This is where we look at things. We can't go back in time and look directly, so maybe we look at isotope ratios or something like that as a proxy indicator. And I wonder if there's any fundamental assumptions in that data and how we analyze that. Could be interesting to look into. Don't have time to deal with that. But, you know, there's questions about how well the Milankovitch cycles would really fit. And again, Dr. Ord could address this much better than I could. But there's a lot of questions as to whether or not those little variations in Earth's axis or movement around the sun really, could those changes in solar irradiance hitting the Earth as a result of those variations really trigger an ice age or not? Maybe not. Again, we're getting into the speculative. And, oops, I hit the wrong button again. You know, part of their reasons for saying, okay, there's been this ice age intrusion and this different ice age, is they'll also look at the stratigraphy, or the layers of the rocks, and the paleosols, or the ancient soils, and they will try to tease out in that, oh yeah, this rock layer and this rock sequence, or this paleosoil, that indicates that there's been an ice age here, and maybe one here, maybe one there, in this different time period, and this different time period. But one of the things that I was really amazed at as I was reading through the literature was how complex and how contradictory these different interpretations of the stratigraphy and paleosols really are. I mean, I even saw one article that was saying, we propose that we totally eliminate this entire classification of rock formations and paleosols because we don't think they really fit in here. Oh, we're just going to vaporize those rocks. Okay. So, no, that evidence is still there. We're just going to totally change how we interpret it. Boy, you see that a lot when you get in here. This researcher says this researcher says, no. We get into these big arguments. You know, creationists, though, have a way of simplifying some things, though, by looking at it from the perspective that there was this really big, massive event called a biblical flood, and that biblical flood would have set the right conditions to trigger not multiple, but one ice age. And, so there's like many things, there's a real dichotomy, a real difference in how we go about understanding things depending on where your starting point is. And so let's move on and get into some specifics here about Kansas. This map's going to be a little hard to read here, probably from where you're sitting, but the little triangles are representing where the Kansas Geologic Survey has identified rocks like this big boy right here. This is a specimen of Sioux quartzite, and Sioux quartzite is interesting. This one happens to be showing a nice conglomerate perspective. This one happens to show some really nice banding. Okay, Sioux quartzite is sedimentary rock that's been metamorphosed, if I understand correctly, and it's not native to Kansas, though. It came from somewhere else, several hundred miles north. But they have found and documented the presence of Sioux quartzite in all the different areas here south of Wamego, Kansas. And they propose that that dashed line would be a boundary for the movement of the ice sheet during the Ice Age to an area about 5 miles south of Wamego. And they've mapped this out for most of northeast Kansas, and the southern margin of where you find the Sioux quartzite is basically along I-70. Extends a little bit south in several places, but typically it's there along this I-70 corridor from Wamego east. Now, there's a nice picture of Doc Rock's truck in relation to a Sioux quartzite glacial erratic up there on the Marshall and Pottawatomie County line, northeast of Wamego. Now the perspective's a little bit off there, but if we were to pull his truck right beside that boulder, it would nicely crush his truck. Now, that's a big rock. Now, most of them aren't that big. Most of them are like what we've picked up here and brought in, or the ones there by my foot. So this area here, the Mount Mitchell, would be roughly right about in here. And not too far from the hypothesized terminus of the ice sheet. This is also up there along the Marshall County line, Pottawatomie County line. This is actually on the north side of the line, so it's in Marshall County. And this is an area where you can find glacial till. And as you walk up along this road, you will see all of this material is stuff that's washed out, and you can observe it washing out of the embankment beside the road. And again, I'm not a geologist, so I can't tell you for certain, oh yeah, this is definitely it, but I'll take it at their word that that's what they say. Now, all of this material on the table up here, except for a couple things, three things. All of this up here, if you want to look at it later, is material that was collected from that location. And so we can find things like ironstone, we can find catlinite, pipestone, which is, to my knowledge, only originates in one location, north up in the Minnesota area. I think it's Minnesota or South Dakota. I can't remember exactly. We got a map that'll look at that here in a minute. Granodiorites, diorites, granites, gneisses, ironstones. Jerry, Doc Rock, was on a quest to get a Lake Superior agate at Lake Superior 12 years ago. He couldn't find one. About 45 minutes literally walk along that road. There it is. There's this Lake Superior agate. He was a happy boy. He was dancing a little jig almost. He was just beaming all the way back. And so he was pretty excited to know that he could go to northeast Kansas and find his long sought Lake Superior agate. And it's kind of interesting. Why would we be finding this stuff coming from up north? Well, we're going to follow a little rabbit trail here. The Mid-Continent Rift is a very interesting geologic feature that extends, some say, from Oklahoma up through Kansas, up through Lake Superior, that area up there in the box, down through the Great Lakes region into Michigan. And we know that there's a lot of igneous material there. There's a lot of very interesting stuff going on there. And again, the explanation is that at one point in the past, the continent started to rip apart there. And you have all this material coming up in. And so up there in the Duluth complex, you find all the iron ores, and there's just a lot of interesting geology up in those parts. Down here in northeast Kansas, just northwest of Manhattan, there's actually several igneous intrusions in Kansas that would be associated with this potentially. And kimberlite pipes, where the kimberlite has come up. It's infused with garnets and magnetite and all kinds of fun minerals that you wouldn't think of as being in Kansas, but they're there. And I should have dug some of those out and brought them, but didn't think about doing that till just now. But oh well, they're actually there, and you can, if you get the permission from the landowner, you can go collect them. But I bring those up because as we look at the Minnesota, the little blue dot, that's your pipestone or catlinite source. We see that these materials that would be associated, particularly up here around Lake Superior, with that Mid-Continent Rift, the granodiorites, the diorites, the gabbros, a lot of igneous material is showing up, boom, right there in northeast Kansas, which is where we collected these materials from. The Sioux quartzites, the big black blob with the blue dot there. And, oh, did you know you could find gold in Kansas? Yeah. I've actually seen it. I was on a field trip a number of years ago where a Kansas Geologic Survey geologist took us to this guy's place north of the Lawrence area. And this guy had set up quite the little placer mining operation. And by golly, he was recovering gold from his creek bed. The closest source of gold to Kansas is Wisconsin, right about north central Wisconsin there. And but you can find gold all the way across Iowa, Missouri, and into northeast Kansas. Guys, don't quit your day job and go buy a gold pan. This he had way more money invested in his operation than he was getting out in gold. And his goal was to be able to get just enough gold to make a ring so he could say he had a gold ring from Kansas. But this is up there in Minnesota where the Sioux quartzite comes from. It's massive cliffs of this stuff, and it's obviously laid down in water. And I wonder what could be responsible for that. Interesting thought. You know, the evolutionary geologist is going to tell you that the Sioux quartzite was the remnants of a mountain range that was eroded out of northwest of there. It laid down in a braided river system. I seem to sniff some speculation happening here. But anyway. Something else that's very interesting is the loess deposits. You know, as the glacial sheets receded, there would have been a lot of exposed, ground up material. And you know, Brian was mentioning this about the mammoths and mastodons that have been found standing up here earlier today. And you know, there was apparently some really impressive dust storms. Some really impressive. And so this is a map of a generalized map of where they have found the wind-blown material that would have been resulting from the glacial till as we understand it, or from the grinding of the rock material and the glaciers receding. And we noticed that most of Kansas is impacted by this quote-unquote wind-blown material, as well as Missouri and a lot of the Midwest and Nebraska. And if you go up to the very northwest corner of Kansas, you get into what are referred to as the Rickery Breaks. Very impressive gullies where the water is eroded out the loess. And of course, loess has this very unique characteristic in that it's extremely stable. It can hold extremely steep slopes without slumping off, which most soils can't do. And so here's a cave, or I don't know, natural bridge. Thank you. Eroded out of the loess. You know, it's not lithified. It's not solidified in any way. It's just able to retain incredible steep surfaces. But loess is very important to the agricultural world. It makes for extremely good mineral-rich soils for growing crops. And in fact, that's one of the reasons why the central United States is the breadbasket of the world. And so you got a lot of minerals ground up in there. Oop, wrong key again. Another very interesting aspect of the Ice Age in Kansas is that the Kansas Geologic Survey proposes that, again, we're going back to Wamego, that ice extended across the Kansas River Basin and created an Ice Age lake. They call it Kaw Lake. And there were other proglacial lakes, and here around Paxico and Topeka areas. And You got a little spillway that we'll look at here in a minute that spills from Kaw Lake down to the lake there at Paxico. Now, those channels aren't very deep because the elevation relief here is pretty minimal. But there is speculation. This is the same map we saw earlier, and I'm pointing out this time, this area here would be the proposed spillway that I was pointing out on the earlier map. And, the...
Jake,
Yep.
I hate to interrupt, but it was 5.
We're out of time?
Yes. If
Oh,
anybody wants
okay.
to go over to we had published that the expo room would be open from 6 o'clock till 7. So if anybody wants to go over there and man your tables, probably now's the time to.
Okay. I'll wrap up really, really fast. So anyway, kind of an interesting idea. Again, very much a proposed idea. Not a lot of hard evidence to support it, but it's an interesting idea. And this is a picture from Mount Mitchell where this ice dam would have come across. They proposed that this ice dam would have been about 500 foot thick here. And that water would have been backed up all the way to Salina, Kansas from there. And when it broke out, though, you have a lot of erosion down the Kansas River Valley. And so from well logs, they can identify that the channel is much deeper in the bedrock than it is today. And the thought is that, well, it would have filled in as the ice sheet melted and receded. So you have this surge blowing it out and then it filling back in afterwards. So Kansas even has its own ice age, mini Lake Missoula flood type scenario. It's also interesting that in well logs, they have identified some channels for a 3 to 4 mile wide river flowing from the west to the east between the Platte River and the Kansas River drainages, filled in by, they say, glacial material. And so that's a very important water source for those areas of northeast Kansas, but it's because there's not much underground water in that area. But so anyway, so dating, there's some interesting things here with dating. They use a method called thermoluminescence. I wasn't familiar with it. I had to go do a little extra reading on it. But by golly, there's some really crazy fundamental assumptions that go with this dating system. Like, you have to know how much annual influx of ionizing radiation that material was exposed to during its lifetime in that system. And wow, how are we going to know that? Well, we're not. But it's interesting that Brown University even says inaccurate measurements of the radiation acting on a specimen. we don't know what those are. And so it makes it very difficult for us to get a good estimate. But yeah, we're going to trot out the dates. 136,000 to 164,000 years ago. Boom! We're solid. Are we? Let's be honest. And a couple other interesting quotes here, and then we'll be wrapped up. The assumed simplicity of functioning. This is interesting. This is actually from a Kansas Geologic Survey researcher. Says, the assumed simplicity of fluctuations in early Pleistocene climate is now known to be wrong. Well, how do we know it's to be wrong? But they come up with stuff like that. And I love it down here. Where all these exposures are of the sediments and paleosols of the same age marking one interglacial interval, or whether the record is more complex is not yet known. But yet we're saying it's known. You know, you gotta love it. And this is Wakefield Dort, published in 1987. And I threw in a few things here real quick about some biology, but since I'm a biologist, but I will note that larger animals are better able to tolerate colder environments. And that's one reason why Texans love to come to Kansas to hunt whitetail, because yeah, they have whitetail in Texas, but they're about this big. You know, they're little guys compared to what you'll find in Kansas. Or wow, let's go from Kansas up to further north even yet and get a really big whitetail. You know, that is a biological reality. Cooler climates bring bigger animals. And they talk about evidence of coniferous forests in Kansas during the Ice Age. Again, that would be an indicator of a cooler, drier climate, because coniferous plants like drier climates. Huge winds, based on the assumptions that we have relating to the lust deposits. I find it interesting they break out mastodons or more browsers eating woody stuff. Woolly mammoths, they're grassland, grass eaters. Here's the ugly reality, guys. Unless you watch the animal eat, you really have no idea what its teeth are doing. Okay? I love to point out to students that, you know, if you look at the mouth of a squirrel monkey, it's a really scary looking mouth. You know, nasty little teeth all over the place. All they eat is fruit. That's it. But yet, we would be trained to think that nasty, scary little teeth are going to be a carnivorous animal. You have no idea what that animal eats unless you watch it eat it. So, you know, big beavers. Got the beaver skull cast back here at the back table. Beavers, 150 pounds versus 40 pounds today. You know, big beavers could eat big trees, I guess. But, and it's also kind of interesting little side note I discovered. They think that the last woolly mammoths only died out, quote unquote, 4,000 years ago on an island up in the very far northeast along the Asian coastline up off of Russia. And, you know, maybe it wasn't even that long ago. But fossils of Ice Age plants and animals have been found throughout Kansas. So there's a lot of very interesting paleontology that can be looked at too, which we don't have time to do tonight. So what do we know? Ice covered large parts of the world during the Ice Age, including potentially parts of Kansas. How many ice ages? Well, that's going to depend on your dating systems and your worldview and what your fundamental assumptions are. The Ice Age deposits in Kansas are extremely complex. And there's some very interesting ways of interpreting the same data that even the evolutionary geologists argue about. And the impact is very impressive when you look at the less deposits. It wasn't just the northeast corner that got hammered. You know, just coming from Wichita to here on Highway 54 or 400, however you want to call it, you're driving through inactive sand dunes that they think are the result of the Ice Age. And so it's even close to where we are here. And so one of the things that we do know is that climate changes dramatically, and it has nothing to do with what you and I are personally doing, other than the fact that, you know, wow, that Ice Age probably was the result of a great big global flood, which is the result of something called sin. So yeah, our personal did impact, but not in the way that the secularists would like you to think. And so But it's a tremendous testimony to the graciousness of God and how God desires all of us to have the time and the evidence to come to know His truth so that we might have a personal relationship with Him. And so with that, I will leave it there. And I guess we better skedaddle.